All right, folks, welcome back to another video. We're working on an '01 ZRX1200, and as you can see, we're already into it. This was delved into by the owner and had a problem with it not running on, I think, 1 and 4. I don't remember which cylinders, or 2 and 3. I thought it was ignition related. Went out to that webbike.japan, whatever it's called, and got these, they're 8mm wires molded on the ends and with some sort of a jumper thing, and so this used these connectors on it, and these things unscrew no problem. For 7mm wire, which is what that XL yellow stuff is, we're going to end up using that to fix all this and probably putting it in black loom. We'll figure that part out later. These are solid core, copper core, XL wire. They're auto parts store stuff, but they're good stuff. I have them on the Sabre over there. I've used them on other bikes too. I have plenty, I believe, here for this short run for four ignition wires. I haven't tested these yet. I assume they're good. But there's a number of problems with this bike, and the carburetors are just one of those problems. The carbs are over there. I have not cracked those open yet, but I did take an air cut valve off the side of it, and all this brownish, gooish old fuel come out that hole. This thing been sitting for a while. The main problem we have right now is the starter, which is out. That's why I took the air box and everything out. The starter is over here on the bench. It has already been gone through by this guy, Rick's Motorsports Electrics up in New Hampshire. According to their website, now I'm waiting for an email confirmation on this, but according to their website, they have a 2 to 3 week lead as far as shipping back to you something like this, because it requires you to send it up as a core. Now, I don't know if they have any of these on the shelf, because you would think they would, because it's the same damn starter as like in a Concourse 1000, I think the ZX10, ZX11, and of course this ZRX12. Being that it's the same starter out of a Concourse 1000, I mean, they built a billion of those. You'd think that there would be tons of these starters out there, like on eBay. There actually isn't a lot of them out there, at least the original ones. And I suspect there's a bearing problem in this one. The way it sounds when you crank it up, it kind of howls. I don't have any footage of that. Anyway, we're going to get into this starter in this video as a separate section. In fact, let's just go ahead and do that now, and then we'll go ahead and get back to the bike and we'll take it over from there, and I don't know, we'll figure something out. This seems like a bearing issue. Spin it over with the battery pack here right now. You get an idea what I'm talking about. You'll hear it. And the way it turns is terrible. Instead of doing 2 to 3 week turnaround, I can make just about anything or find little bearings for it. Let's take it apart. Let's see what's going on inside of it there, because we gotta get Rick's to fix it. We can always pop it back together, or shit, send it to him in pieces. Sometimes Rick's has one on the shelf, 1 or 2 or however many. They'll wait for a core to come in with payment. Then they'll ship out one of their previously rebuilt cores, and then I guess when they get to it, they'll rebuild this and backfill their shelf stock, their par level for this particular starter. That's what I understand that they have typically done in the past. This sucker going to jump a little bit because of the inertia, but should be manageable here. Hang on. Okay, ready? I just lost my ground. You hear it? I mean, it's got a howl when you do it otherwise, like when you have it cranking the bike, and this thing's obviously running at a slower RPM because it's under load. You can hear it, it's not running too well. That's what we're going to assume is a problem. Let's get this out of the way. Okay, I think I mentioned before that this bike also has evidence that the tensioner for the starter / alternator arm is got evidence it's banging up against the clutch basket, just that outer edge. I should be able to put in a clip on, or at least some sort of B-roll on that at some point, if not now. We are going to do the Quick Pete's tensioner tamer on that. This has nothing to do with that. That's a totally separate thing that happens on these ZXs, and the ZX11, ZX10, the ZRX12. It's very similar, if not exactly the same tensioner situation, but we get the tensioner tamer from, again, Quick, Pita Quick, KWICK, I guess it is. ExpensiveLightweightShit.com. I got some marks in here. I got 3 in the back on each side, 2 in the front on each side. And we'll take these out. I mean, I don't know what the hell I'm doing, but we're going to do it anyway. Since when does that ever stop me? Oh, that's not even an 8. That's smaller. Probably a 7. Yeah. 7 is the same as 9/30 seconds too, by the way, or close enough. If you're working on old GMs or something, doing in particular interior parts or electronics, they love to use them 9/30 seconds. Don't need those on. Take my squints off. I've been doing other things while I'm working on this. I'm working on the Saber, doing the front trim piece that covers, I'll show you over here, it covers the horns. There's one of the horns back there. I'm getting it all painted up, front and back. Second one's up on a shelf out of the way, getting, paint drying. I'm cleaning up all the trim, and I'm probably going to end up painting this plastic cover that goes over the whole thing that says fuses here. But the little tang that snaps in on the bottom is broken, so I'm probably going to try to fabricate some sort of a spring steel one out of some scrap crap that I got laying around. Then we'll paint it up. I'm not going to show any of that. I'm just telling you why all this crap is up here on the bench. That's why I don't have a whole lot of room. Back to the task at hand. I don't know what I'm doing. I don't know if there's a way to easily reset these brushes back in when you already got the other one out. When the thing goes back together, I don't know. I'm sure the brushes are back here since we got power right here. And it gets ground through the body, of course. Thinking we can take this front off. Yeah. Will the whole armature go with it? No, it will come off. I thought it might. I thought this whole front would go and the armature would stay in there. The way we can inspect this front end. There it goes, right there. See? Thrust washer of some sort. Looks like it's plastic. Feels like it's plastic. And a steel washer. So the plastic goes out, just for my purposes of putting it back together, away from the armature. Kind of lay it like this so we don't screw that up, which I probably will anyway. Get that O-ring out of the way. This is the part I'm not sure of. I'm sure there's some sort of trick to this. Like I said, I have no idea what I'm doing. I'm guessing. I'm sure the brushes are back. Oh, it's just a oh, okay. Whew, thank God. I thought the brushes may be inside this cover. So there's the brushes. And the commutator.
Commutator. Commutator.
Commutator, you dummy. I bet you there is no problem with the commutator or the brushes because, again, well, I don't know if I mentioned this before or not because, to be honest with you, I haven't shot those clips yet, that footage. 26,000 original miles, and this guy's owned it like almost since day one, if not from day one. Among the other problems that we're dealing with as far as the carbs and so forth, this is one of them, and this is very unusual, I find, to have a starter on such a low mileage unit go, but it's clearly bad, and it's clearly some sort of bearing issue, in my opinion. Of course, opinions are like assholes, everybody's got one. Take this, there's a thrust washer on the back here. Thrust? Thrust? Yeah, there's a third one. And that's a different thickness, so I would consider this more of a shim pack than a thrust washer. This thing did have quite a bit of axial movement, but I don't find that to be too terribly unusual. Alright, let's just pop it out. Here we go. And there it is. I didn't think there'd be any trouble with this commutator. I mean, I don't have any problem with putting these on the lathe and giving them a skim cut and going in there with like a prick tool and cleaning out the, I forgot what those are called, those segments between the commutator, that's the insulatory segments. I don't have a problem doing it. I've done it before. I don't see a need. The brushes, there's no problem with these brushes. I mean, I didn't think there would be. There's a problem now because I probably won't be able to get them back in. But no, I'm sure we will. We'll figure out a way to hold these in. Got to be a way to do it. They did it at the factory. It's not even that dirty. I don't suspect any magnet problems. Just don't suspect any problems at all except some sort of bearing. So let's focus on that. We'll focus on the covers. So what I'd like to do on this one is I'm going to take this front one and put it back in. See if there's a lot of play in here. And honestly, I don't know if there is or not. I could tell when this thing was together, you had most definitely a bunch of radial run out on it. Look at the back one. That's a bushing in the back. And that's not bad either. But it's drier than a popcorn fart. Could it be as simple? This bushing is like dried out. There is rust in there. Let me show you. There's like rust inside that bushing. I wonder if it's as simple as that. Because we can polish this commutator up with some wet or dry, no problem.
Commutator.
This is another common mistake I see.
Commutator! The shaft looks good. There's not a lot of play in this one. As far as this bearing goes, I'm not 100% sure, but it certainly doesn't look all that bad. I wonder if it's as simple as that this thing was just so dry on the back one that it was heating up and starting to bind. Needs a little lubrication, and put it back together. That might be all. Whoa, what's that? Where did that come from? Can anybody tell me? I guess it goes in here, huh? Some sort of a thing. Yeah, okay. That does go in there. I didn't see it before. And you can see the outline around here. In this case, it would be the plastic one because the steel one goes up against the armature. And, oh yeah, okay, and that kind of allows us to see that there is a seal right there. I didn't realize that before. I didn't realize that. You know, I just don't see that bearing being bad. There's plenty of lubrication in there. The only one that doesn't have lube is back here. I wonder if it's that freaking simple. The way this works is you have the O-ring that I just took off around the outside here that protects oil from coming externally outside the engine. Anytime I've ever pulled an alternator or a starter off of one of these engines that has an alternator, you know, like the types of alternator like the ZXs have, whenever I have taken these off, the O-rings are never, ever, ever bad. I don't know why, but they're just never bad because this doesn't allow oil to come outside of it. It does allow oil to go inside of it, and that seal protects the motor from that oil, which is ergo engine oil, because that's what lubricates that bearing. I cannot see any scenario where, with the mileage this thing has on it, the way this shaft looks and the way this thing feels, that front bearing needs any attention at all, and the seal feels like it's going on there pretty well. So I am not going to even suspect anything wrong with this front cover. I think the entire problem lies back here. I don't believe there'll be any problem with the magnets. We can check what we can check and make sure that everything's good, do a little cleaning. There's nothing wrong with these brushes whatsoever. There's a shit ton of material, as I said before. Shit, I'm all for just putting it back together and seeing how it works. I bet you it's going to solve it. This thing was cranking a little slow because this thing was binding up on the back here because of lack of lubrication. Now, it could be a cast iron bushing on the back of it, and I don't see why it wouldn't have any lubrication. At least something. Can't think of nothing else. Rotor segments don't have any marks on them like it's been whacking against the permanent magnets. Alright, let me clean up this crap and we'll see if we can get it back together and try it. Alright, we need to revisit that last statement. Because when I push this in, we spin this. Let me put it up closer to the mic. Yeah, I would say that front bearing is smoked for some reason. It's running real rough. That should not be that way for a needle dick bearing. So I'm going to document the seal number, which is a BC. Yeah, like I can read that. BC1693. Oh, I can't read that. Hang on. All right, the number is BC. That's Bravo Charlie 1693G. There's no dimensions on the seal except a 4.5. It's listed, that's the only one on there. So I'm assuming the number itself might have something to do with the dimensions. I'm looking it up online. It comes up as a 13.5 millimeter by 24 by 6. No, I don't think that's no way. Well, 13.5 would be the ID. It looks right. 24. Yeah, that does look right. 24. And the width would be 6 mil. So that's about right as well. So that 6 mil is about a 1/4 inch, close to a 1/4 inch. So it looks about that width. It's a single lip seal. I'm going to try to get the seal out without damaging it. We can just reuse the seal, but if not, I basically know what it's supposed to be now. So let's take a stab at it at least. I think stab is a good word for it because we're going to end up stabbing ourselves most likely. Ultimately what I want to do is I'm going to go over to the lathe. I'm going to make a push-in tool because it looks like this bearing, I won't know for sure until I get the seal out, but I'm not sure which way it goes, but it looks like the bearing gets pushed inwards from the outside here. But again, I'm not sure. There's maybe a shoulder up inside there it sits against. I can't really see that. We'll figure it out. Because I think that front bearing is smoked. I don't know why it would be. It's very strange since it's bathed in oil. I don't know. Bad bearing from the start. Stranger things have happened. That was no drama. Usually it is with me. Excuse me, I got gas too, of course. Ugh. Self-inflicted drama. You know, there is plenty of seal life left in this guy. There's absolutely no problem with it whatsoever. I probably had that zoomed way out of frame. I'm an idiot. Alright, so there is the bearing in question. Sure feels like it's rough. Rough. I like it rough. Well, it would appear that that bearing is maybe, oh, okay. I think there's a shoulder on that end of it. You see that? I think that's the shoulder. I don't know. I don't know anything, but it's not all the way up to it. But it would appear to me that it would have to get pushed. Did I say that before? That way, inbound. Yeah, I think I was right because that's the inside of the bearing right there. I can't see the number on it right now either. Doesn't look like you have anything to push on except the bearing center race. Why in the hell would they do that? I think we're going to blow this thing apart getting it out. I know needle dick bearings have a little bit of play like this in them, but I mean the needles and everything are like moving all over the place. This thing is absolutely trashed. And no wonder. I don't understand why. Make a tool like I said, even though it's going to hit the inside of the race, and then heat this up a little bit. I'll probably spread it out a little bit, you know, and then just push it out. That might work. Stuff is about as round as a concrete block. Okay, 6, 10, 11, so we're going to go a little smaller than that. About 16 thou. So let's just take it 8 on the side right now. Might be big still. That's okay though. I like it when it's big. And in today's lathe lesson, we will learn how not to use a grooving tool as a turning tool. Well, we don't have the right tooling. We got to do what we got to do. In other words, give it more relief this way. Make sure it's nice and square. There we go. That's what I'm talking about. Oh yeah. Yeah, I can get way over there now. We were actually hitting on that bore. On the center section. Well, try this. That's some gun out of the way. There we go. Yeah, I got a really solid purchase on that now. That was the problem. Okay, I need to thin this out just a little bit more. And then I'm going to take it out. I'm going to part it, take it out. We'll see if we can press this thing out. So I'll be right back. I'm just putting it in the middle and pushing it. It's going now. Maybe it's catching enough of that body where it's not going to destroy the freaking bearing. And there it is. And it didn't. Okay. Well, this bearing is a BTM it's a Koyo bearing, so BTM 141912A, 14, well actually it's 13.5 allegedly according to the specs online, by 19 by 12. So 13.5 is the shaft diameter, and then 19 would be the OD where it goes into the housing, and then 12 is the thickness that way. And I can't find really anything solid as far as a hit online. I don't know where Ricks or other starter manufacturers get these from. Partzilla's got a shitload of listings on these dual whatever rolled over needle bearings, but you don't know what the size is. I don't know. So we might have another one here that's perfectly good shape, but it ain't a Kawasaki. So that wouldn't that be the first time that a Honda part saved a freaking Kawasaki or some other brand? Yeah. I'm not surprised considering, hey, it's a Honda. See if this comes off with limited amount of drama. And down deep inside there's a bearing that looks almost identical to it. And a seal that looks even better, but we'll use the one that came out of it. Actually, that's even a better shot right there. Now, what would happen if that was the exact right bearing and it was in perfect shape? Would I win some sort of like an award or something for that? Okay, that's obviously out of the ZRX starter. This is the MB0, the old Magna. This is from a Magna, by the way, MB0. Or an MB0, if you're an alien and your ship's parts manual references, I don't know. But if you go here, it's got a seal on there, so it's a little draggy because of that, but this thing is like nice. I think there's our bearing. We can get it out of here without destroying it. We'll press it in here, put the seal back in, finish cleaning up the rest of this. Maybe just use a tiny bit of like molly grease or something that don't sling on the back here. See if we fixed it, because I'm pretty sure we're going to be able to do so with this. Meanwhile, I'm going to see if we can find some new ones of this, but I don't know where Ricks gets those from. Maybe I'll email them. You know, I wouldn't be surprised if they can't find a bearing for a starter. They just don't use that starter. Even if you send it in as a core, they'll just get another one that has a good bearing in it and rebuild that one and scrap the one that has bad bearing, or, you know, pilfer whatever parts they can use from it. But I would not be surprised at all if that was the case, because, oh, that's a tight one. I'm going to have to work on this one off camera. Camera. Yeah, I wouldn't be surprised at all that they just say, yeah, no bueno, we're not going to use that part of it. And then, who knows? All right, I think I have an answer on what I was talking about just now in regards to Ricks Motorsports Electrics. I sent them an email asking them about that bearing, see if they had one or how do they get a hold of them if they need them and so forth. This is the response to that email, because I specifically mentioned that bearing and the bearing number and the size of the bearing, and said, you know, if you have one, I'd like to buy it from you. Looking into our system as to what goes into the starter upon rebuilding it, in other words, a core that you ship in or send into them, the bearing is not listed in the breakdown. That would be their parts breakdown on their computer. Sometimes the tech replaces things that are not accessible to us in the office on the computer, I assume. That's the important part right there. I will say, they continue, our starter motor turnaround is far quicker than the stator rebuilds. We do them in just a few days. So there's two things there I'm pretty sure that I kind of guessed at that I think this verifies. They can't get that bearing either. If I can't find it, and I'm pretty good at finding obscure parts, they can't find it either. So when they say sometimes the tech replaces things that are not accessible to them in the office as far as a parts list goes, they're taking a starter motor, another starter motor, and they're cannibalizing that part from that starter, just like we did with that MB0 starter. It's got to be the case, because that's how I read this. As far as the turnaround goes, well, I can imagine that the starters would be a quicker turnaround. They don't have to wind those, you know, as far as the stators get rewound and so forth. Whether they have one on the shelf or not is irrelevant. Irrelevant? Yeah, irrelevant. What they have done at some point in time, even if they have one on the shelf that got a bearing replaced, they stole it from another starter. I bet you what they're doing is they're going through these used starters. Perhaps they're buying them on eBay, on other sources. And I actually bought one. I have another one coming in from eBay. Exact same starter as what we're working on here. So I'd have extra parts in the future. I think that's what they're doing. I think they're getting old starters and then pulling crap from them as needed, yeah. So I think that answers the question right there. And I highly recommend Rick's Motorsports Electrics. I want to make that very clear. They are the go-to place on starters, stators, regulator rectifiers, the whole 9 yards. But I think this clarifies just what I said in the video as far as, you know, kind of guessing as to what the status was on a part like that. All right, I got it out. Didn't destroy it. It looks really good. Definitely the same bearing. It goes by the numbers a little bit differently than the one I just took out of the ZRX starter, BTM 141912A. This one that came out of the MB0, the Honda one, 14 BTM 1912A. All the numbers are there, they're just in a little different order. So there you go. I think it's going to work. I just feel confident it will. I don't know why the other bearing is bad. We'll just reuse the seal and Bob's your uncle. All right, back together real easy, no problem. Let me start here on the back side. I got some B-roll to show you on this. As far as getting that commutator through the brushes that want to spring in, there's, you know, each brush is in a little rectangular box, if you want to call it that, and it's got a little slot in the side for the wire to clear. You know, that's the place that you want to put something to kind of jam up the brush so it doesn't push against the commutator while you're trying to install it. And so I just made these little pieces of sheet metal. And as you can see from this clip here, all you do is kind of stick it between the spring and that little box. And this bridges that spot on the back of that little box that the brush goes in. Shove the rotor through and then get that pass there and you're all set, no big deal. Now I checked the commutator. After the fact, normally I would do that while it was still out, but I forgot. So I just put the meter on auto resistance. A quick check of a variety of segments to make sure that there was good resistance rather, like 0.1, 0.2 ohms or whatever it's rated at. All of them are about 0.1, 0.2. That sounds about right. To make sure there wasn't any open segments. I didn't think there would be, but I did that anyway. I put the bearing in, of course, that came out of that MB0 starter. That was a lot better than the one that was in here. Instead of pushing it in on the regular press, I decided to push it in on the milling machine using the fine down feed. That's so much more accurate on top of the Kurt vise to push something like this in. So that was actually pretty simple to do. And this is all lubed up, engine assembly lube, and of course the seal is back in, and so are the two little shims in there. The ones one is metal and one is probably Delrin, like nylon or Delrin plastic. And of course the three that are on the back here, the shim pack. So this feels really good. There was some axial movement before, but there seems to be less now. I can't explain that since the shims and everything that went on the front of the back are exactly the ones that came out. I don't know. It could have been that playing that bearing, that radial bearing play. Now, I'm not going to lie to you, I feel a little bit on this one too, but it just may be the way it's designed on those needle bearings. Certainly a lot less than it was. So let's hook it up to some power and see how it sounds at least. That bushing on the back side, I'm almost 100% sure is like cast iron. That would be really a good bearing material for dissimilar metal, like, you know, turned and polished or turned and ground shaft like on the end there. And then you have a cast iron bush, or it's definitely not bronze. That's fine. But I put a little bit of that molybdenum disulfide stuff in there, just a tiny, tiny bit. I think it needs a little bit of lube, so hopefully that kind of helps that out a little bit too. It sounds good. A lot better than it did. Yeah, a lot better. Now that it's running around a little bit in there. See how quiet it is now? I think it was mainly that bush on the back side there without any lubrication in there. And we got a little bit of grease now. I only put a very small amount in there, and that shit doesn't sling like a regular grease does, which is why I used it. We'll go ahead and get back to the main bike stuff and get this installed at the appropriate time. So next time you'll see this is when we're actually like cranking it on the engine. I hope you got something out of this part at least. Okay, now's the time we're going to get into putting the tensioner tamer in on this bike. I'm going to kind of give you the Reader's Digest version of it. The instructions for it are on his website. I'll put a link in the description. It does not come with the kit. Speaking of which, this is the kit. We'll go over the parts here in a moment. You do not need to drain the engine oil, even though the service manual says to remove the clutch cover you do, because they're assuming the bike is upright. You can lean it over on the side stand, which is what I have right now, on the lift. If you have a small lift, do not do this. Probably flip the thing over. This lift weighs way more than this bike, and I have a really long thing. Well, that's beside the point, but a bar that goes across the back that I'm favoring that way right now. There's no way this is going to topple over. And I've got a board behind the rear wheel so it won't roll away. I do this all the time. It's quite handy. Now disregard this thing here. This is like a aftermarket racing bung plug cover hole thingy. Fill hole cover. And it's got a little pin here. So we're going to get this out of the way here. We're going to leave this in. We don't need to take it out. I showed you a clip before. I'll remind you, looking down into that hole of just cranking it over. And you can see that tensioner banging and making that noise. It was just banging back and forth. And when we take the cover off, show you a really good depiction of where you could see it was contacting, what I believe at least is contacting the outside cover or the outside body of the clutch basket itself. I forgot exactly what Kawasaki calls that. First things first though, clean the area you're going to take this apart, because we need to take all these bolts out. Now some of these clutch cover bolts, and I'm kind of doing this, you know, generally speaking, some of these clutch cover bolts may be different lengths. So if you want, you can take a piece of cardboard, lay out the holes that line up to the holes on the cover, punch some holes in the cardboard and put your bolts through. That way you know the exact alignment of them or the orientation when you go to put it back together. Like for example, I'm sure these two are way longer than the rest of them here. And there also may be some that require Loctite, because they go into an oil gallery or an oil area. Now taking these bolts out on any bike, clutch cover bolts, alternator cover or stator cover bolts or pickup coil cover bolts, I don't recommend you do this with power. I recommend like a T-bar wrench like this, because sometimes they can be seized, you'll snap them right off. But if you're doing it by hand, you will be able to feel that the bolt is kind of stretching or twisting, and then you stop and start banging on it and doing your normal thing. And I generally take them out in a cross fashion. These definitely have thread locker on them. That's the factory stuff. Yeah, I'm pretty sure it's 1, 2, 3, 4. And they all have non-permanent thread locking agent to act as a sealant. That one's kind of tight, you know, so going gentle with it. The threads are okay, it's just that thread locker. There's no aluminum on them. It's a good thing. Here's the page in the service manual for clutch removal. It starts, of course, with the clutch cover removal. And take the bolts out and use the pry points labeled as C on here to pry the cover off. So Kawasaki was kind enough to give us 2 pry points, or 3 pry points. One here, one there, and one there. You can see this one in the back quite clearly. It'll be right there where that little tang is. And then the other one is up top here. And then down in here somewhere, which I can't quite see right now, but I'll go ahead and get in there and get that if we need to. Usually I just be able to tap it off. Now when you're taking these covers off, any bike, okay, any bike you're taking a cover off like this, especially when they're leaned over. Sometimes there are little thrust washers on the end of shafts, and they come out during the process of removing the cover. They can fall down and go in the motor, so just be really careful when you take this off. Kind of look in there as you do to see if anything's about to fall, especially if it's got a mating surface for like a pin, kind of like the outside of a pilot bearing would have to support the length of a particular shaft. It might have something on this end of the cover, and if it has a little thrust washer, it might stick, it might not, and fall into the motor. So just got to be careful of that. It's already loosening up. There you go. And we're good. This one, okay, this one does not have any dowel pins. I thought it did. I just couldn't remember. Yeah, so there's no dowel pins aligning the cover. And here's the deal. If there was something up inside the cover here, like I was describing before, like a rod that comes out that helps support the end of that, then it would absolutely have some dowel pins to align that, but it doesn't because it doesn't have that feature. So I just forgot because I couldn't remember. You know, the last time I did this was a while ago. So we'll go ahead and take a rag, lay that sucker down about yay right there, it's fine. And the first thing we're going to do is take, I'm not going to use this one, it's not clean enough. I'm going to get yet another clean rag. We're going to shove it in there and protect that opening that goes in past the main gear on the clutch bath, the clutch drive. So if we drop anything, it does not go down inside the motor. And of course, don't forget to take the rag out. When you're done, that would be bad. Okay, so here's the tensioner in question. This is the tensioner we're going to be dealing with. Let me zoom you up a little bit. And to do this, we have to hit this with a really big hammer. No, just kidding. We have to take it out. So these two bolts here hold it in place, and then it'll just come out. But what we want to do first, we're going to run some wire ties through here and kind of hold it in a position where it's not springing so much against, it doesn't want to spring out, in other words, as we're taking the bolts out. Because once the bolts are coming out, this thing's got some spring tension on it. And it's going to want to keep going. And when the bolts just have a couple of threads in the end of them, if it forces away from the casting that it goes into, the aluminum, you could actually damage the threads there. I just used one of my big black ones. We're going to use the green ones later on. It's actually later on in the steps that we actually use those for a different purpose. You can see the tensioner is nice and loose and it's not trying to spring back up there. Okay, now the first thing we do is look at the wear surface here, the pad. This is like a coated surface with some sort of a, it's plastic obviously, but it has some sort of a coating on it. It does show a little bit more wear than I like to see. Right up in there in that little black spot. Now as far as this oil goes, in case you probably already noticed that this oil is like reddish oil. And at first when I did the top end work as far as the valve clearance and I popped that head cover off, I was like, why is the oil red? Did somebody put ATF in this thing? Apparently, I didn't talk to the owner yet, but apparently somebody has put in that Castrol red or some similar product like that, which is like a high-end synthetic. This is the other side of the block that this chain runs on. And so we're not going to touch that at all, that just stays. This is the side we're going to be dealing with right here. This is what's in the kit. It's all it comes with. It's a little block with a gun drilled cap bolt that's through holed. That's important. Cap bolt, I think that's a M5, yeah, and 2 nuts. You're only going to use one, one's a spare. He gives you 2 in case you got to take it off to readjust it. It isn't right the first time, and he wants you to use a new nut every time. And you can see those nuts have their lock nuts in themselves, but they're also going to get Loctited. And this is the Loctite that he wants you to use is 263. It just comes in a little thing, one of these little, kind of like a blister thing. You pop it open and drizzle out the Loctite that you're going to use. Okay, I undid the wire tie and this thing sprung right out because it has quite a bit of spring pressure on it. Now there's 2 springs in here. There's one in here which is like the ratchet pawl that holds an angular tension on this shaft. That is the tensioner lock on the original design. It's basically like your screen door, the hydraulic screen door closers. When you put that little piece of metal after you open the door and you slide it down to keep the door open, kind of prop it open, that's the exact same theory. That spring pulls this in where it gets it in an angle and just jams it up. This is the part that just doesn't work anymore after a while. And then inside here is the big spring, which actually provides the spring tension. Now that's still going to be in force as far as utilized on this, with this modification. What we need to do though is, we'll get this spring out because we're going to take this out. This has got to come out. And how you do that is according to the instructions. So you have a wide part, it's a rivet. So there's the head of the rivet there. You said head. And this is the bottom of the rivet. We're going to grind this bottom rivet out as close to the body of the tensioner as possible and hopefully not go into the body. You want to stay away from the body completely Little nick, maybe okay, but I tried not to do that even. And then just drive this out with a pin, like a drift, and then the spring will come with it. Yeah, we'll get the spring out. We don't need either of those two things with this. We're going to replace essentially this locking mechanism with that block that I showed you, excuse me, aluminum block. And it will articulate with this rod, as I will show you here shortly. There it goes, see? I just needed to be patient. I didn't touch that hardly at all. Maybe a teeny bit, but it's more like a chamfer around that hole than anything else, so I'm okay with that. That'll work. This is what the pin looks like when it comes out. I think we need that spacer. I'm pretty sure the spacer is what we need. Yeah, we need the spacer out of it, but not the little arm itself, so do not lose that little spacer. Quite certain that this roughness around here is where the old tensioner arm was hitting, because I don't remember that ever being a thing on these. It looks like it's been hitting right there. Look at these little edges right here, these little gussets that are cast into this cover. You can see that the witness marks of that thing hitting are right there. So you know for a fact that this is all secondary to that arm coming back and whacking this thing. Just by the grace of God that this thing hadn't come back so far that it destroyed the clutch basket. And if I remember, I'll get you some clips from his website and also some photos. I don't remember which is which he's got on there that illustrates the point as I'm going along here as far as what can happen with this when the tensioner completely takes a shit. This is that corner that was hitting. You see how it's shiny right there? And it's not over there. So yeah, that's where it's been hitting. All right, I got a couple more things to cover with you, and we're going to stop right here because this tensioner is bad. You probably noticed it before I did because I just didn't pay close enough attention. I did see that this worn section existed, and this is a Teflon coating. I figured it would still be enough Teflon on here to utilize this. But I looked at Pete's information on his website and on the instructions. He said if any of this is worn through the plastic, it's scrap. You got to replace it. What I missed, and you probably saw, was, see this little lip right here on this left side? Well, it's completely gone on the right side. That is a guide lip to keep the chain in the center of this, you know, because it's not all that tight really. I mean, it's just through a pin there. It's not precision. So we are most definitely going to have to replace this. Now, I went through all the procedure because I just didn't realize it at that point, of taking that clip off the back side here, which you have to grind that rivet, just because it's part of this whole job. Even though this is not the one I'm going to be using, the one that's coming in, I found two of them on eBay. One is worse than this. But the other one, it's kind of hard to see the Teflon coating the way it's laid in the picture. But it's really inexpensive. I can see that both of these edges are intact, and it's in Daytona, and it's really inexpensive, about 32 bucks with tax. So I went ahead and ordered that. I'm hoping that the Teflon will be okay. It definitely, like I said, definitely has these two edges, and it will be very usable. But that particular one, I'll show you a picture of it now. This clip with that rivet has already been removed, and there's some sort of a different manufacturer or different kit installed with an aluminum block of some sort with a set screw. Is a pin with a circlip on it. So when we get that in stock, all I'll do is pop the circlip off, drive the pin out, and we'll essentially be looking at this, a different one, a replacement one, hopefully better, in the same exact status. All right, folks, we are to the point where we got the package in the mailbox for that replacement tensioner. As a reminder, here's the old one. And she's pretty bad, and I'm glad I took the time to go ahead and find one on eBay. I haven't looked at it yet. Hopefully it's good enough, because as a reminder, this one's all beat up. Let's open this up carefully. Now this comes with more than just the tensioner. It comes with the fixed block. I'm gonna make sure I don't scratch that surface. And it comes with the chain, and it comes with, I don't know, something else. If I can get this thing unwrapped, we'll see. I hate this crap. So here's that block. We're not going to need that. Nor are we going to need the chain. Oh yeah. Disregard this part right now. We're going to be shitting in high cotton with this one. Okay, you see that gray surface compared to the black? That's a Teflon coating. That is in absolutely stellar condition compared to this one at least. Come on, get off the damn towel, you son of a gun. And you can see both of these edges. I mean, there's a little, well actually that's just overlap of the Teflon along that edge. If a little of that's coming off, I'm not worried about it. But the edge is still there. I mean, look at this. One on the right here, it's gone. This was the only one on eBay that was worth a damn. The other one was even worse than this. So it's either that or we got to buy a brand new one. Okay, what this is some sort of aftermarket manual tensioner. Probably the kind that you put tension on it and then load a set screw in here and then tighten it up. That is not, I repeat, not how Pete's tensioner works. We will show you that here momentarily. But I'm going to go ahead and get this out off camera so you can see a little marks on the body here where they ground off the old one. It is kind of a sloppy job, but I don't think it's that bad. And then we'll take this pin out and get this thing out of the way. Don't need that. Excuse me, I got gas again. So we should be looking at the same thing. Here's the old one on the right and here's the new one on the left, the replacement one. And it has D on it for dumbass. That's perfect for me. And yeah, she'll be fine. I'm just going to clean it up a little bit more and inspect it a little bit more. You know, you can see again, they kind of did this a little sloppy, but it's not terrible. We got to use it. We got no choice. And I'll show you how this goes in. Okay, as a reminder, these two holes here are the bolts that hold the tensioner against the crankcase. These have already been cleaned out before and degreased with brake clean. Did that a couple days ago when I ordered the replacement tensioner. These are the two bolts that hold the tensioner in. They're the only ones that are black. I've cleaned those off and degreased them as well. Very important to have everything degreased because what we're going to do is put some blue Loctite on those. But first, what you want to do per the instructions is essentially cock this thing with one of these green ties, just like this. You'll see it in the instructions as well, against the spring. The objective is to get this to line up to these two holes and push the chain up like that and be able to line those bolts up and get them in. If you can't do that, you need to compress this a little bit more, tighten the wire tie a little bit more and get a little bit more compression on it so it goes in a little further, goes up to the holes a little further. It looks like I need to do that. Now the other thing that the instructions don't mention is you really want the slack on this side of the chain. Because if you don't, then when you go to set this tension up, it's going to be a little on the loose side. So I have most of it on this side. What you can do is you can just take a wrench on this a little bit. You're going to be going against the starter clutch. That's not a big deal at all. And make sure that your tension is on that side. That's not in the instructions either, but I found that to be the case, that you need to do this. So like right there. You see how that kind of went back as soon as I touched it, because the way we're sitting on a particular position of the crank, it wants to fall in that direction. So now it's taut up here and loose down here. That's what you want. And make sure that this guy is free to move. That's very important. Don't get this thing locked up inside there. Okay, now we can get to the holes, no problem. So we'll set that aside for the moment. I want to make sure that there's no oil or anything inside these holes either. You know, so the bolts don't drag it in. Now all we're going to do is put a little blue Loctite on the bolts. And we're going to put those bolts in. We're going to torque that up to 87 inch-pounds. And we'll just line it up and screw them in. Here we are. See, if you don't have this thing cocked and restrained with a wire tie like this, it's going to be fighting that spring. It's going to be very, very difficult to do this. That's why it has to be cocked first. Double check, inch, pounds, 87. 1, 2. Okay. So you can see this edge here that was previously missing. There's obviously one on the other side too, to help hold this chain in this position. And so this tensioner is fantastic. So the next thing we do is make sure you leave the rag in and leave this on and just button it up. No, I'm kidding, of course. We're going to go ahead and take the wire tie out, cut it out in pieces if necessary. Now this is going to put tension, because of the spring, up on here and kind of tension this for you anyway, but it may not overcome that slackness. You may have to turn this a little bit to make sure that there's tension on this side. I just found that you get a more accurate adjustment on the manual screw we're about to put in. Make sure that it's in the right tension, because it's very easy to put this together and then you go and test it and you see this thing bouncing a little bit more than you want. And that's because there was slack on this end and you didn't notice it, and this thing wasn't strong enough to pull it up. So, excuse me, so that's really what you want. Just like when you do cams on a engine, you know, like a KZ or something, you're going to be measuring certain things and checking certain things with tension only on one side of the chain, and installing certain things as well. And this is kind of the same situation with this. So this is nice and tight up there, and spring pressure up against that. Okay, now for this part. You take your manual tensioner, this guy here, make sure it's screwed all the way in. It'll come pretty much like that. And we're going to turn it this way, like that, and we're going to shove this rod up inside that this bolt is, drilled all the way through, so you can see that it goes up inside there. Gun drilled. We're going to take this and put it up to about right there. And we're going to take the spacer that came out of the original one and we're going to put it right there. You got to be very careful, it'll drop through. That's why you need a rag there. Then we're going to take the bolt, not the nut, just the bolt. We're going to put the bolt through just like that. And now you're done. Just kidding. Now we're screwing you all up on this one. Now what we're going to do is we're going to screw this out until the head of that cap bolt goes up against the bottom of the tensioner. That's what provides the manual tensioning force. In other words, it keeps it from bouncing back. Move that out of the way so you can see a little bit better. But we don't want that down yet. Now this is the part that's a little subjective. What you want to do according to instructions is tighten this up as tight as you can by hand. In other words, put your fingers in here and just crank it as much as you can. I have found that that is not tight enough. Personally, I have found that that is just not tight enough. I've done only 2 others of these, maybe 3, and I found you have to put a little bit more on it. So what I'm going to do is I'm just going to take a pair of needle dick pliers and I'm just going to tighten this up a little bit more so it's putting a little bit more pressure on it. To lock this, we're going to take this back out, which is why there's no nut on it, and we're going to put it in the vise and we'll tighten it up that way. Okay, so this is all I did. I made sure these were clean. Go in here and just give it a little extra, just like that. I think that's better than just by finger tight. It's just something I found in doing these. A couple I've done, I think on all but one, I had to go back in here and redo it. That's why it gives you 2 nuts. Because once you put that nut on this with some red Loctite on the back side here, then you can't use that nut anymore according to him. So what we're going to do for our own sake is we're going to mark this with some white paint and mark the body right there so we kind of know where the 2 of them are. Let that dry a little bit. Try to keep it in that spot. When we go to tighten this up in the vise, we'll just put a wrench on the lock nut. And he says to tighten it about 15 foot-pounds, reasonably tight, like you tighten a handlebar clamp bolt. And that's what I've done in the past, and I've never seen one of these loosen up. You don't use any Loctite on this. I'm just going to do this off camera. We'll just go ahead and tighten that up. All right, we're all tight. You can put a 6 mil hex in that on the top. That's why you left that part of it, to hold it in place, and then torque the crap, bejesus out of this. I went a slight amount more because when you tighten this, it wants to pull it down a little bit. Now we're going to go ahead and reassemble this just the way it was. I degreased the inside of the spacer really good. This is all ready to go. And we'll shove that back up inside there. Carefully put the spacer in. That's why you have to retain it from the original unit. It's a little bit of screwing in, that's fine, as long as it's not really hard, because you don't want to actually get metal shavings back there. I just find that it has to be this way, otherwise they loosen up. Now we go to the final part, which is a little tricky, but not terrible. And that completes the install once we're done with that. Alright, we're going to take the Loctite 263. I got to have one glove off of this, so you're going to have to put up with my gnarly fingers, sorry. And we're going to take it out, and according to his directions, you have to shake this for 3 minutes. Okie doke, this is going to be impossible to show you, so I'm just going to describe it. Break the cap off of this. We're going to take this wrench in this angle like here, put the single-use nut like that, so we can take advantage of this bend to get it in there. We're going to put a crap load of this red Loctite on this nut while it's in the wrench, a very liberal amount. And then the clock starts right now. What you want to do is kind of reach behind here with the nut and the wrench, and take your 4mm Allen key, and you got to start getting that threaded in. It's really not that hard to do. And once you get it threaded in, start tightening it. Now the instructions call for this being torqued up to 75 inch-pounds. I generally do not use the wrench on this one, just my preference. I can get this good and tight, you know, German torque spec. It ain't gonna come off on its own, trust me. That is plenty tight right there. Well, it's not completely yet because we gotta take the rag out. Let's do that. Reach behind here and get a little bit of that extra Loctite off. Doesn't need it. Be in there. Believe me, that's tight enough. I got that thing really tight. I just a little bit leery about using a torque wrench on a 5mm fastener. It's bad enough on a 6 like these. I know how tight to get this. So that's tight. That nut's on, it's tight. This is tight. Tighter than I think you would expect it to need to be, but like I said, I've found in the past that it just needs a tiny bit more. So when you're putting this in, this cap bolt in, it kind of fights you a little bit. If it goes straight through, I think that's too loose. You want it to have a little bit of pressure there where this thing doesn't quite line up to the hole all the way, but you don't have to bang it in and chew up the threads on it. Maybe turn it in a little bit like I did, and that's about it. I'm confident that this will be the final adjustment because, like I said, I've done a couple of these and that's how I've done the last ones. I'm going to go ahead off camera right in here, this little space where it kind of curls out as far as the tensioner goes. Squirt a little assembly lube down there so overnight this is going to weep its way down between the chain and the Teflon surface there. Just give it a little bit of extra lubricity for a first start. Don't worry about this unless it's really chewed up. It's not. Whatever chips it may have produced have been long gone through the oil filter, so don't worry about it. There's no evidence of it down here anyway. I'm out of time for the day, so what I'm going to do is put the cover back on loosely again. I'm going to hold on loosely but not let go. We're all ready to go. I drained these already. I'm going to go ahead and get the throttle positioning sensor out first. These pilot jets, slow jets, are freaking tight. A lot of times it's all you need to do to get these to loosen up. Yep, just like that. All right, let me tell you what the dummy did. The dummy forgot to put the bolt in up top here to seal the rear air box to the front air box. That's where the air filter is. So there's a big gaping gap right there where air is escaping. Yeah. And I forgot to put this funnel on, this intake funnel. All these are calculated and engineered into the operating dynamics of airflow. That's better. Man, this thing got a wicked badass intake pulse, that's for sure. We're up over 30 centimeters of mercury. Wow.
Wow.